progressive wave equation given as y equals to 0.005 sine, open bracket x, open bracket again, 0.5x minus 200t, double bracket close. Here we are expected to calculate I, the amplitude. That is the first thing to calculate, the amplitude. Alright, A. Then the second is the frequency, alright, that is F. And then frequency, amplitude, frequency. The third one is the wavelength, alright, and that's lambda. And the fourth one could be wave speed, right? And that is V, so to say. So what do? It's very simple. We write a solution, alright? And then once we write our solution, we bring down the equation of plane wave given, which is y is equal to 0.005 sine, brackets open x, brackets open again, 0.5x minus 200t, bracket close and bracket close. Okay, without wasting time, what we're going to do here is just simply to compare this equation with the general equation, okay? And the general equation is given as y is equal to a sine bracket open, right? 2 pi ft minus 2 pi x all over wavelength and bracket close. So with this, we can now compare the two equations and then find out where our amplitude, or rather the amplitude of the wave particle, falls. So at this point, the amplitude of the wave particle falls within this. That means amplitude A is equal to 0.005 meters. That's the amplitude. So that comparison holds this way. A is equal to 0.005 and is measured in meters. Because that is, look at this, that's the position of A when being compared. Okay, that's it. So A means this, 0.005 meters. This is answered. This question has been answered. Then the next one is frequency of the wave particle. What do we do? This is where frequency parameter is found, and you can see F. Frequency parameter is found at this part. So we compare this part with this part. But there is something here. We need to rewrite this. Because this X, this parameter X, is irrelevant. Doesn't have any role here at all. By the time you multiply X times this, it becomes X squared. And then S times this becomes minus 200tx. We don't have that in our general equation. So it's completely odd. And secondly, it's going to tilt this equation into quadratic equation where you have S times S squared. And that will make us run into some kind of problems. So we don't have something like that. So what do? We restate this equation. How do we do that? Very simple. We write y is equal to 0.005 bracket open. We do away with this. We remove this completely and we have just 0 point. Rather, we have 200. Okay? We have 200. We bring this to this side, take this to the other side. And it becomes 200t minus 0.5x and then bracket close. As we are taking this to this side, there will be inverse of the sign. This becomes positive at this side, this becomes negative to the side. And that is what we've done. Now we have the original equation we can now solve. we can now solve to find the frequency of the wave particle. Alright? So let's go. What do we do? Pull this out and then compare with what you have there. So let's pull this out. This is 2 pi ft is being compared with 200t. That's it. So what do we do here? Look at this. Look at this very well. T, we take care of t. And we are left with just 2 pi f. 2 pi f is equal to 200. Alright? So the next thing we need to do here, look at this. We want to transpose in order to make f the subject. So how do we transpose now? By simply dividing both sides using 2 pi or by 2 pi. And that holds this way. Here we have 2 pi. This becomes 2 pi. This side is 2 pi. Alright? So this 2 pi, we take care of this. Therefore, f, the frequency f is given as 200 all over 2 pi. And this is measured in hertz. Soft. We can still simplify further here. If we find the value of pi, multiply it by 2, we keep it, and then use 200. 200 divided by whatever we have here. We give us the concrete value of frequency measured in hertz. Otherwise, take your options. If your options have something like this, it means this is the appropriate option. You should choose that. That is how to find the frequency. So we have found the amplitude. We have now found the frequency of the wave particle. The next thing we need to find now is the wave length. So how do we find the wavelength? Still use comparison method. We pull out this. You can see the wavelength of the particle is found somewhere here. And it's minus 2 pi x over wavelength. We pull this out and then compare with whatever we have at this point. So let's just do that immediately without wasting time. I have minus 2 pi x over wavelength, right? It's now being compared with minus 0.5 x all over 1. The reason for over 1 there is to fractionalize both sides for them to have equal weight. So, because we have fraction this side should also have fraction by dividing it with 1. Alright? So, let's go. Something common is x. So, this x takes care of this. Something, again, that is common is minus. Minus takes care of itself. And simply we are left with just 2 pi is equal to over wavelength, so to say, is equal to 0.5 all over 1, right? Okay. The next thing is for us to make wavelength, lambda, a subject. And if we do that, wavelength is equal to 0.5 all over 2 pi. 2 pi. And wavelength is measured in meters. And this holds. It holds. If you want to simplify further, simply press 2 times the value of pi, which is 3.142. Once you get that, put it here and then do small simplification, just division, and whatever you have should be the value of the wavelength. I repeat, 0.5 over the value of 2 times pi, whatever it gives you, should be the value of the wavelength measured in meters. Soft. So we have now successfully found the wavelength. Can you see? We're making progress. And another thing is wave speed. We can now have wave speed, which is V is equal to F wavelength. So how do we find this? How can we find this? You can do this. Just what you need to do here, let me guide you. We already have the value of frequency. Look at frequency here. Simplify this further. Put it here. Okay? Then look at the value of wavelength. Multiply. Okay? Multiply. The value of frequency here, the value of wavelength here. Whatever it gives you is the wave speed measured in meter per second. Meter per second. Alright? That's how to find that. You can see we have used this simple, plain progressive wave equation to solve and found 4 parameters: amplitude, frequency, wavelength, and finally wave speed. Don't forget to subscribe. Give me some thumbs up. I want to read your comments. Should any of these steps not clear to you, feel free to put it in the comment section for further discussion. I am signing out now.